It is crucial to rewrite things first because the only way we can take the derivative is if it's x to a power. This is not x to a power, so let's invest the time to rewrite this. So if I squared out the numerator, I get 25x squared. And if I cube the denominator, I get 64x cubed. So I'm just going to continue on. So this is the number 25 over 64 times 1 over x. Oh, and let's take the time to rewrite that as x to the negative 1 power. Now I can take the derivative. So to take the derivative, we say f prime of x will be, carry along the number, right? Any number multiplied times an x, you carry it along. We take the derivative of this, so I bring the negative down, and I'd have x to the negative 2. Okay, let's look at this next one. Oh boy, looking ugly, but let's just peel off the numbers. So I see that 2 pi and root 3 are numbers multiplied times the x. Right? There's no addition, no distributing, it's just peeling off numbers. So if I asked you, I gave you that g of x was equal to 4x, what would the derivative be? Wouldn't it just be the number 4? That's exactly what's happening here. So the derivative would just be that number. Okay, let's make sure we separate this. So this is the same as saying the square root of 3 times the square root of t cubed. And let's think about that again. You know how to rewrite this as an exponent, right? This is the power 3 over the root 2. Okay, so now to take the derivative, I carry the root 3 along, and then I would take the derivative, so I bring the 3 halves t, and if I subtract 1 from that, that would give me 1/2. And that's a fine answer. Okay, so for this one, we have to separate it, and we're keeping in mind that a, b, and c are numbers. So I'd have ax squared over cx to the 4th plus 8x cubed over cx to the 4th. So there's no other way of doing this other than going slow and rewriting it. Okay, so let's see. I know that a and c are numbers. So I'm just going to pull them out in the front and think about what are the variables I have left. I have x squared and x to the 4th. And so then if I subtracted the exponents, right, you know that's what to do. So 2 minus 4 gives me an x to the negative 2 in the numerator. All right, let's do the same thing over here. So I carry the b and the c along. I'm sorry, the b over the c along because they're numbers. And then if I subtract these exponents, I get x to the negative 1. Now I'm ready to take the derivative. So I carry the number along, right? Carry this number along, then take the derivative. So I have negative 2x to the, subtract 1 from the exponent, negative 3. And let's go do the same thing. So plus b over c, negative x to the negative 2. So if I wanted to clean that up a bit, I get negative 2a over c. And then if I wanted to rewrite the negative exponents in the denominator, doesn't matter, but sometimes that's going to be useful for us in the future. And then I'd have minus b over c over 1 over x squared. Okay. Now, this is a question you're going to be asked about 100 times before we finish the semester. Okay, so what do we need for an equation of a line? Don't we need a point and a slope? We do. Okay, it doesn't matter what order you do it in. So a point is going to be like the x, y value, right? Oh, look at that. I think they give us the x value, don't they? How do I find the y value if I have the x value? Don't I use the function? Yes. So if I put negative 2 in there, I get negative 2 to the 4th plus, oops, squished, sorry. Negative 2 to the 4th plus negative 2 cubed. Okay, so let's make sure we know what this is. Negative 2 to the 4th is a positive 16 minus an 8. So that gives us the y value of 8, right? So, comma 8. So that's the xy point. And you know, to find the equation of a line with a point and a slope, the easiest way, you can always do the mx plus b, but the easiest way to get the answer is going to be using this. So you take the y minus y1, the y value, x minus x1, the x value, and then you plug in the slope. Okay, so the point we're going to use is negative 2, 8. But then let's think about it. How do I find the slope? So the slope of the tangent line is the derivative at x equal negative 2. So first I have to do the derivative, and then I can plug in the x value of negative 2. So taking the derivative of this, using the power rule, 4x cubed plus 3x squared. Next, I plug in negative 2. So I get 4 negative 2 cubed plus 3 times negative 2 squared. So this gives us 4 times negative 8 plus 3 times 4. So I get a negative 32 plus a 12. So that's negative 20. Okay, so that's the slope. So let me write it above here, putting everything together into this equation of a line. Okay, so I'd have y minus 8 equals negative 20x plus 2, using that xy point and then this slope.